welcome. We are going to look at a graph of a quadratic function, and we're going to determine four things: our y-intercept, our vertex, whether our graph has a maximum or a minimum, and what is our axis of symmetry. So I'm going to start with y-intercept. The y-intercept of a graph is they're saying, well, where does your graph cross your y-axis? I know that my y-axis is the one that goes up and down, so I'm going to follow my graph, and when I see that it crosses my y-axis, I'm going to put a blue dot. So I have to ask myself, well, where does it cross the y-axis, or what is that y-intercept? In this case, the answer is 1. If they ask you to write that as an ordered pair, I would say it is 0, 1. The next thing that I'm going to look at is going to be my vertex. So I look at my graph and I say, okay, if I follow this graph from left to right, it comes down and then it hits a point and it curves and goes back up. Where is that bottom point where it turns? And I'm going to mark that in red. And I have to figure out what is the ordered pair of that point that I marked in red. And that ordered pair would be -1, 0. Now we have to determine, is that red dot, that vertex, is that a maximum or a minimum value on that graph? And if I look, that is the lowest point on my graph, so we would call that a minimum. Finally, I move on to the axis of symmetry. And in order to find the axis of symmetry, I'm going to draw a line, a dashed line, that is going to go through my vertex that would essentially cut this graph in half. So here is my dashed green line. And you can see here that it goes right through my vertex, and it would cut my graph in half so that if I were to fold this graph along that line, I would have the same thing on both sides. So my axis of symmetry, they want the equation for that line. Anytime you write an equation of a line that's a vertical line, it's x equals, and in this case, it's x equals -1. That equation is going to be connected to your vertex. You'll notice that my x value in my vertex is -1, and my equation for my axis of symmetry is also x equals -1. In this example here, again, we're going to be finding four things: the y-intercept, the vertex, determine whether it has a maximum or a minimum, and then find the axis of symmetry. So I'm going to start with the y-intercept, and again, I'm going to follow along my graph, and I'm going to see where this graph crosses the y-axis, and I'm going to mark that with a blue dot right there. That point is at -8. And again, if you had to write that as an ordered pair, you would say 0, -8 is your y-intercept. Great, so now I'm going to use my red marker, and I'm going to mark the vertex. So if I look at this graph, I can see where the graph turns is right here. This graph is facing downward, so my graph comes up to the top and then it turns around and comes back down. So the point where it turns is my vertex. That ordered pair looks like it is 3, 1. So I'm going to write the ordered pair 3, 1. Because if I start at 0, 0, I have to move over 3 and up 1 to get to that point. Now if I look at that graph, I say, okay, well, is that a maximum value or a minimum value? This is a maximum value. It is the highest value on that graph. Then the last thing I have to look at is my axis of symmetry. As I told you before in the previous example, we're going to look at that vertex, and we are going to draw a line that goes through that vertex that serves as an axis of symmetry. So you'll see on my paper that I have drawn a green dashed line that if I were to fold this graph in half right there, it would be symmetrical. That is my axis of symmetry. So my equation for that is going to be x equals 3. And you'll notice that the value in my vertex ordered pair, the x value is 3, which is going to match that axis of symmetry.